Alright, so we are starting chapter 2, and we're going to look at the derivative and tangent line problem. If we go back and kind of think about what a derivative is again, remember it is the slope of the tangent line. So I'm going to draw a picture for us to look at. Okay, so if you have a sketch of the graph, and when we think about a derivative, we have some function, and I'm just going to call it f of x. Okay, so here's my function, and I'm going to call it f of x. And we know we can't find the slope of a tangent line, so in the past, back in chapter 0, we thought about the idea of a secant line. So I'm going to draw in a secant line. So this red line represents a secant line. Okay, if we think about the ordered pairs, this first one to the left, I could say that it is x comma f of x, because we're at some spot for x, and then obviously the value for y we can represent with f of x. And then if we have some sort of change in x, we don't know exactly what it's going to be, but I'm just going to put some sort of change in x. Okay, we know that this new ordered pair up here would be x plus the change in x comma f of x plus the change in x. Okay, now with finding our derivative, we know it's the slope of our tangent line, so I'm going to also sketch in a tangent line here at x. We talked about the idea as well that the smaller that the change in x is, the closer our secant line slope will match our tangent line slope. Okay. Now, if we want to find the slope of the secant line, we can say it's the idea of y2 minus y1 over x2 minus x1. We're just finding slope. Okay, so if we use the notation from our graph, that means it'd be f of x plus the change in x minus f of x all over x plus the change in x minus x. Okay, now we really want to find the slope of our tangent line. So when we think about the slope of our tangent line, we would want the change in x to approach 0. Okay, so the way that we're going to indicate that, and we also, when we think about derivatives, we're going to say it's f prime of x. Okay, so the way to do know what that is, we say it'd be the limit as the change in x approaches 0. We're going to use that slope of our secant line, but we want it to be approaching our tangent line. That's why we have the limit notation added in of f of x plus the change in x minus f of x all over. You'll notice on the bottom you're just going to be left with the change in x. Or sometimes people don't like using the change in x, so I would also, you could use h instead. It's pretty common. You could say f of x plus h minus f of x all over h. This is really key. Put a box around it or star it. Okay, so let's look at a couple of examples. Example 1. I'm going to ask you to find the slope of the tangent line, which if you think about it, it is our derivative. Okay, and it's going to be the function is g of x equals x squared at the ordered pair 2 comma 4. Okay, so the first step is I'm going to write down that formula, and I'll use h because I find that students usually like that best. But remember, h is representing the change in x. Okay, so in this case, I guess we're using more g instead of f. Okay. All right, so it'd be the limit as h approaches 0. I'm going to plug in x plus h into my function. So it'd be x plus h squared minus x squared all over h. And then from here, it's just a matter of simplifying. I can't plug in 0 right away because I get 0 over 0. So I'm going to go ahead and FOIL this out. I get x plus xh plus xh plus x squared minus x squared all over h. If I keep going, it's going to be the limit as h approaches 0. My x not x squared, excuse me, h squared at the end here. My x squareds get crossed out, and notice that what I am left with, I could factor an h out front, and I'd be left with x plus x, which is just 2x, plus h, all over h. Strategies factor and cancel, cross those out. So then I'm going to plug in 0 for my limit, because now I can do that, so just equal 2x. But we want it to be at the point 2 comma 4, so I'm going to plug in 2 for x. So therefore my slope of my tangent line is 4. Okay. Alright, what if I asked you from here, so example 2, I'm going to say find the equation of the tangent line for example 1. Okay, so I know my slope is 4. I know I have the ordered pair 2 comma 4. And again, you can either use y equals mx plus b to figure out your y-intercept, or you can use point slope, y equals y1 plus m times x minus x sub 1. I'm going to use the first equation, but you can go about it either way. I'm going to plug in 4 for y, 4 for m, 2 for x. I just need to solve for b. So therefore b equals -4. So my final answer is going to be y equals 4x minus 4. If I were to graph my original function, the x squared, and this tangent line, you would see how it hit the graph at 2 comma 4 as a tangent line, and you could kind of check your work that way. Alright, so that's today's lesson. If you have any questions, let me know.